Hello, I'm Liping Liu, and in this fall, I'm going to offer deep neural networks. Today, I'm going to give you guys a preview of this course. First, why do we need deep learning or deep neural networks? Because they are playing very important roles behind many applications. When you use Google Translate, you're using some deep neural networks behind. And then these neural networks are also used in applications such as auto driving and game playing. In this course, I'm going to teach you guys some principles of constructing these deep neural networks. I put 3 prerequisites for this course. The first one is linear algebra. In this course, we will have many tensor operations, and then your knowledge in linear algebra will assist you understanding these operations. You also need to know calculus because we will need optimization to train these networks, and then we will need the computation of gradients, and then you need to know how to compute gradients from these networks. You also need to know basic machine learning knowledge. You should have taken COMP135 or some equivalent courses, because in this course, we're going to use some basic but very important concepts. For example, training, testing, split, model selection, overfitting, and underfitting. I'm not going to cover in very details for these concepts. Okay, course objectives. After this course, I hope you guys can set up a learning model for a typical learning problem. For example, if I give you guys a bunch of images, some of them are labeled. Can you train a neural network to predict labels for other images? You will need to know how this model work, and you need to be able to tune deep neural networks to get decent performances, which means you need to know how to use a series of learning tuning techniques. I will cover the following content in this course. The first part is about principles of all neural networks. For example, how to compute network gradients, how to optimize our neural network, and how to overcome the overfitting and underfitting problems in the context of deep learning. By the way, I'm going to teach you the tools for constructing neural networks, such as TensorFlow and PyTorch. I'm going to cover a list of network architectures. The first one is feed-forward neural network, which is the basic one. The second one is convolutional neural network, which is widely used in computer vision. For example, image classification, object detection. I'm going to talk about the recurrent neural network, which is designed for sequential data modeling. For example, time series data, text data. When you have data without labels, you need to do unsupervised learning, and autoencoder can do that. So the autoencoder can learn some patterns within your data. I'm going to talk a little bit about the Bayesian models, such as variational autoencoder and GAN models. If you want to get a better treatment of Bayesian models, you can go to Professor McHugh's class, Bayesian deep learning. There he has a better treatment. I'm going to cover a list of techniques for training deep neural networks. For example, setting model hyperparameters using dropout, batch normalization, early stopping. So all these techniques are very important to train a good model. Finally, we are going to use the book Deep Learning, written by Goodfellow and a few others. So this is a recent book. And there are also 2 related courses at Stanford. You can go to their course web pages and take a look first. Thank you. See you guys in the fall.